Welcome to the Rutgers Cooperative Extension Compost Management School. These video presentations are designed to help you learn the principles of manure composting and the proper utilization of composted manure. In this video, we will hear from Jean Bonhotal on structures and facilities for manure composting.
Okay, so we're going to talk about structures a little bit. First, I'll say we have compost maps in New York State where you can look for composters. So you can find all the composters in New York State. All types of composting, not mortality composting. We don't put those on maps because we're not trying to point them out. But other types of compost so that people can buy compost and people can find a place to compost material that they don't want to compost. So that's why we have our maps in New York. On those maps, we have probably about 300 different compost facilities. And my point about all that is probably only 10% are under some kind of a structure, are under roof. Most of our composting, large-scale composting especially, is done outside with no cover, with no roof, no shed, no anything. But I am going to talk to you about all the different types of situations that you'd be in. So we're going to talk about pads, we're going to talk about structures, and we're going to talk just briefly as much of siting as we did last time. So considerations for siting: away from ground and surface water, out of fields that are being grazed in particular. And that's more because the animals are going to get into those. If you have a windrow there, they're going to be walking all over your windrow. And that's what we usually find. And then your windrow becomes flat and you're like, oh, that's not what I was trying to accomplish. So that's the reason we'd keep it out of there, not so much for animal sanitation or any of that stuff. Rotate windrows. If you're doing mortality, you may want to walk around a whole field and then incorporate each time. Use that as tillable ground the next time so that you're not concentrating nutrients under those. Convenience. Sites have to be convenient, but they also can't be right on top of the neighbor, the story that I told before about putting it right on the edge. That's any kind of compost. And we have to think about seasonality. We have to be able to get to it. And those are reasons why we might improve where we're composting. Okay, we might change our surface, our ground surface, and not compost on bare ground. We might put up a structure because it's going to work better. Again, away from all of our water sources, and if we can till that land at some point, that would be great to get it back into agriculture periodically. If it's a permanent windrow site, then we're probably going to put some kind of a pad down, so we're not going to put it back into agriculture. This is what we would like to avoid altogether. And I don't know if you can see that well, but it's a disposal pit, and I have some good pictures of different disposal pits. When we're dealing with mortality or with manure, burying it isn't the answer. We can have a soil pad. And soil pads, what we usually do for a soil pad, it's a slightly improved pad. The soil type has to be proper. It can't be a clay, because if we're on clay, we're going to keep having problems and getting stuck. And that's most of our problem. The reason to put a pad down, more than for groundwater protection, is for your equipment to be able to run on that surface. Because when we put divots, when we put tracks in pads, that's when we cause problems. Because if we have a tire track, we're going to fill it up with water when it rains, we're going to have mosquito problems or fly problems or whatever, and that's what we don't want to have happen. Standing water should not happen on a pad. We want it to be 1 to 2% slope, so that water will run off of it very slowly. We don't want it to sheet run if we're on a hill, on a 7, 10, 12% slope. It's going to go very quickly off that hill. We don't want that. We want it just a slight slope. When we create the soil pad, we may go through and till it, take some of the large rocks out, compact it, and then till it and compact it again. So we're trying to really make a harder surface when we do that. This is an asphalt millings pad, and millings are when they take the asphalt up, concrete and asphalt becomes a waste product. We make it small and we make it into like an aggregate again. And this happens to be DOT, so they always have the end of the load that needs to be dumped someplace. And so they dumped it and they roll it out. When we put that in, put it in the summer. If we're going to do a recycled asphalt pad, put it in the summer, because if you put it in the winter, it's heat dependent. It will be clumpy, it will be lumpy, and it'll be a mess. So put it in when it's hot, and then the heat of the piles will help flatten it out, and you might have a roller in there that actually helps you make the pad in the beginning. If it's recycled concrete, that is going to be just like gravel, same as bringing gravel in, so use it the same as you would gravel. Cloth and gravel is one of my favorite pads because it's less permanent than concrete and asphalt. If I decide that I'm not going to compost any longer, I don't have to leave that chunk of concrete or asphalt, and I don't have to take a jackhammer to move it. It's much more environmentally friendly to do it that way. So what we do, topsoil's at a premium everywhere, I'm sure here as much as in New York. We actually take this topsoil, if we want to create this type of pad, we'll take the topsoil off of this pad and push it over to the side, and we can either sell it or we can use it someplace else or whatever, because we're not going to need it there. So we're getting down to a more of a mineral surface. Then we'll put cloth down, and that can be something that's an ag fabric. It's like a polyester, we call them geotextiles. It's permeable, yes. It acts as a filter, basically. So if water is going down, it filters some of the material, some of the stuff that goes through it. So that goes down, and then we'll put a gravel base on top of that. And at that point, we're going to, so if we put gravel on clay, what happens? It's going to sink in, and we're going to lose that gravel altogether. If we put the cloth down there, it's going to stay, the gravel will stay separated and stay on top. And it works very nicely. They use it in playgrounds, they use it in road building, they use it in a lot of places. But it allows for stability. You want to have your coarser stuff, so big rock can be toward the bottom, but this is all even. This was all uniform. This is actually Cornell's compost pad. This is the wild pad I was referring to, stark white. Anybody have any ideas why that's so white? What it is? It's granite. That's a granite marble pad. Their waste gravel in Vermont is this. So that's what they're using as their pad. Pretty wild. They hadn't used it yet, so it's really, really clean. You work with what is the most economical for you to work with. And they happen to live right behind the plant that made this gravel. They needed to get rid of it. It works. Again, pad surface, depending on your type, and this can even be manure composting or food waste or whatever. If you're not turning all the time, constantly, weekly, monthly, whatever, which you don't have to, you can have grassed filter strips in between your windrows. And anytime you're able to achieve that, do it. And if you're not able to achieve it right on the pad, then make sure that you can achieve that on the downward slope. Put grass filter strips in. I think they're our best friends. They allow us to make mistakes. Again, another grassed, and this is a turned windrow, but they go ahead and mow between those periodically so that they keep the grass and weeds down. One of the problems with having a grassed pad is that if weeds grow in between, so if you have weedy things growing in between, the weed plants are going to go to seed, and the seeds are going to go into those piles. So we encourage people to mow around their facility. Okay, that's how you keep weed seeds. We've killed the weed seeds in those piles. We know our temperatures killed those, and we've done tests. So we know that that happened. It's the blow-in that's going to cause weed seed problems for when you go to sell that material. So be careful about that. This is a forced air system, and again, it's in a big warehouse. This one is being controlled. It's a really, really old warehouse, but it's a forced air system. And the forced air tubing is around the edges, you can see. This one allows for a lot of air on the outside and wherever there are those tubes, but not in other places. So it creates preferential flow in the pile. Why do we need a pad? Why is it going to help us to have a pad when it comes to quality of our compost? If you have an improved surface, you're going to pick up less soil. If you have an unimproved surface, you're going to pick up more soil. That can work to your benefit or your demise. So it works both ways, and I'll explain that. Most of our compost is sold, and we're getting almost into our marketing part, but most of our compost is sold as a topsoil blend. That is, you can make just as much money with a topsoil blend as you can with a compost, a pure compost. So it's something to think about. So do I want to entrain that soil in my compost? Maybe. So think about that strategy. Maybe not. Maybe I want the high organic organic matter content. And if I entrain that soil in there, my organic matter is going to be lower. So we have to think about that. With a soil pad, we lost more nitrogen, and with a soil pad, we'll have more concentration of nutrients. So we may want to do, we can go either way. I'm not saying which is a better way, because there isn't a better way. Regulation may come into play, and they may say with certain feedstocks, we need to have a pad, and with certain feedstocks, we don't. I'll just tell you one quick anecdotal story, and that is our DEC requires all of our leaf and yard waste compost to be done on pads. And everybody thought, well, that's to protect groundwater, of course, right? Isn't that what we all think? If we put it on a pad, it's going to protect groundwater. Yes? No? Maybe? Okay. No, it doesn't, because if it falls on that asphalt pad, all of that leachate is going to go someplace. It's a 1 to 2% slope. It's all going to eventually wash to some part of that pad and go right straight down into your water. So you're not protecting the groundwater by putting that pad in. They have their pads in basically to run equipment on. If we wanted to protect the groundwater and collect that leachate, we could, either in a tank or in a swale, a lined swale, where we could use that and maybe even put it back into our windrows. Then we're protecting the groundwater. So you have to think about how much protection is needed of that groundwater and whether it's a problem or not. Compost covers. I don't tend to be a huge proponent of compost covers because it eventually creates another waste product. But it can work, and there are reasons to do it. With compost covers, we may keep weed seed out so we don't have to mow around our site. We also, what a compost cover actually does is it keeps moisture in, but it doesn't allow the rain to go in. So it keeps the pile moisture more constant. And that's one of the reasons why people might use covers. I think they would be best to use for a finished product, not for an active product. Because in an active product, you have a lot of dynamics happening already, where you're losing moisture, and you may want to lose that moisture. When it's a finished compost, it's going to suck water. It's going to suck moisture. So when it's a finished product, it's finished and it's like a sponge, and it's going to suck all that moisture in, and that's when you really need your covers on compost, or putting it into a shed or something like that. That's what that's my feelings on how that works. Hoop houses. There are a whole lot of different types of hoop houses. Almost all of our poultry people compost in some kind of a structure. Not any particular reason, though it's easier for them to do it that way. Their compost, or their manure, is a fecal sack. It tends to be, unless it's dried, it tends to be problematic in composting, and it can dry a little. We can allow it to dry in the compost pile. We can allow it to dry on a belt on its way out of the house. There are different ways to deal with it, but we tend to, because it's easier, compost in a structure. The hoop houses can be used different ways. We can compost up against the walls, and if we're composting against the walls, then it needs to have some kind of a barrier, and you guys are familiar with the Jersey barriers or the highway dividers. The hoop houses can be hooked to those, and that could be a more economical way to put a hoop house up, because you don't have to pour cement or have a wall built, a wooden wall structure built. But it allows you to push against those walls to do your turning and stuff like that. So if you're using a structure, I encourage that. If you look, and you guys probably have the same, in New York at least, we have a lot of salt houses for when we're putting salt on our roads. The salt houses, they have their hoop houses also, most of them, a lot of them are. They put on a really tall wall. Why do they put that really tall 10-foot wall on there? Because they've got large equipment that has to function inside of that thing. And I encourage finished composting to be put in some kind of storage. In the Northeast, we have a lot of rain. When it's finished compost, it sucks moisture, and you can't get it screened if you need to in the spring because it's too moist at that point. If you can get it into some kind of structure, it can be this or it can be something else that works better. This one has a wood wall, and that's a nice, and they're doing theirs in the middle. They're using a windrow turner, so there are all different ways to use these, and that's what I wanted to show you. This was developed by our prison system. 42 of our prisons compost their food waste, and a lot of them do it in this type of building. Cheap labor, they can build these things easily. They're pole barns. They have a 3/4 wall on them, And that allows them, that's a reinforced wall so that they can push against it because they do turn against those walls. We also put what we call a sugar shack roof on them. So for our maple industry, we do a lot of roofs that are like this. Okay, they're overshot, thank you. And then not much moisture comes in through that, but it allows for a lot of air circulation. The 3/4 wall allows for a lot of air circulation in that building. Nice building. If you have snow that's going sideways or rain that's going sideways, yeah, you'll take in a little bit of moisture, but not enough to worry about it. I'll show you another version of that. So you can see the walls in there, and they're composting against the wall in there. Lots of good airflow. Don't need to put walls, total walls up, because that's just going to impede things. Another pole barn, and they're composting poultry in this one. They have curtains on this. They're free-ranged in the barn. I mean, the poultry, when they're alive, would be free-ranged in this barn. So they just pushed all the stuff right into a pile, and they're composting it because of a disease issue or a depopulation issue or whatever. I don't know what the situation was. This was in Virginia. So they're putting them in there. They're doing it undercover, under a roof, and as we said, that's a good way to help with disease control. If we have an airborne disease, we'd like to keep it undercover and in a building. Here they are in the windrows. They put a biofilter over top of those after they've created their mix. So they created the mix, mixed the litter with the birds, and then they put a nice biofilter over top of it, and they allow that to work. For a pathogen problem, 7 days for avian influenza, we would kill the avian influenza in that pile. So we tend to leave it static, as little manipulation as possible, and keep it inside. The time temperature is enough to kill the avian influenza, probably in shorter than that, but most, I think in Virginia and the South, they've pretty much gone with the 7 days if you follow this procedure. So you really have to follow procedures when you're doing that, and that's how we regulate more in New York, is we regulate by process. Have you turned it X amount of times in X amount of days? Have you, were your temperatures this high in a static pile for X amount of time? I would say temperature is it's a combination. So when we pasteurize milk, we need X temperature for 30 seconds, right? Okay, so that's how we pasteurize. So we have that really quick pulse of heat, and that takes care of it. When we have composting, because we're using a natural process here, our temperatures are not that high. Our temperatures are going to be in the thermophilic range. Maybe we'll get up to, we don't really want to get above 160, because we're going to start sterilizing our whole compost, and then our compost won't work properly. So we want to be, so what we're looking for is duration here. And there's an extremely comprehensive pathogen study on our website on time and temperature of pathogens. And it will tell you all the different pathogens and all the literature that's occurred, that's been searched through the last 50 years. Because some of this work was done with cooking and pasteurizing and all that kind of stuff, but we know that that happens in a short time. What we're seeing happens over a longer period of time with a lower temperature. Different storage sheds, important. I like the multi-bin systems. You're going to see most of these are multi-bin, sometimes with dividers, sometimes with just discrete piles underneath. You don't necessarily need dividers all the way along. The bottoms can just touch. These are more structured bins, and these are for discrete batches. And a lot more are used for mortality than for other types of compost. So this happens to be one that they were using for a butcher waste. And they have sides on them. You can see there are air holes in these when we're building them, and you're going to see a bunch of these. But there are air holes in there, and that allows that air to circulate around there and to facilitate the process. These are passively aerated. They could be actively aerated, so we could force air through them. One of the reasons that I don't encourage a lot of forced air composting is because we usually try to force too much air through the compost. That works against what we're trying to do. We're trying to force air in so that we can speed up the compost process, and what we do is we dry that compost out, those feedstock out, and we shut the system down. So we've just slowed ourselves right down, and it's not going to work. So what we want to do is, if we're using forced air, we're going to use it very judiciously. a little bit of forced air, you know, every hour, maybe 3 seconds on, 4 seconds, 6 seconds, 10 seconds on per hour, something like that. We don't want to have it on, an hour off, an hour on. That's not going to work. It's going to dry our system out. So we might do a little bit of that drying, but if you're already running a dry system, a system that stays fairly dry, it's going to dry out and it's just going to stop. I know more farms that have turned their forced air off than that use it. This happens to be in a building and they've used the Jersey barriers again to create bins within, and this happens to be some biosolids composts that are being done on a very small scale. It's a very small municipality that are doing these, and they've got several of these things around, and they are using them. They're using some forced air in there so that they can push that material through more quickly. This is another bin system that's being used for butcher waste. I was in Brazil last week teaching, and this is our some of our Brazilian compost. They chose to use wood. We can use wood for our structures, but we have to be careful. It's going to compost eventually. So they use a tropical hardwood here that would last longer. They have the option of doing that. We probably don't have the option. Though we could use cedar or locust or something like that from the north and have a bin that we know is eventually going to start rotting, but that we can use for a longer period of time. If we use something like a pine or something like that, you know, even an oak, it's going to go pretty quickly. It's going to start showing wear. So they chose to do this. Their system is set up so that they can take all of these sides out. So if they want to access it from different sides, those sides are on tracks, and they can take these sides in and out of the tracks. That's a nice system because you can add more air, you can get machinery in from different sides, okay, and they're individual bins. What I would do in their case is set it up so that it's a trough. So it's a whole column instead of distinct bins. We don't need those distinct bins. That's just another side that's getting in the way. We can do it as a windrow, a contained windrow, if that's the problem, if that's what they think they want to do. Then we can offload from one end, so we fill all the way back, and then we can offload, because there's no wall on that other end, we can offload the oldest stuff, and that'll be finished compost. The newest stuff will be at the other end. So we use it as a windrow, and I think that's a better way to do it. We do 1 million pounds of fish guts. Used to do 1 million pounds of fish guts a year from Lake Ontario, and that's the way that they were doing it. They were doing it in a long windrow that was somewhat contained. This one is a metal one, and when you make, it's aluminum, so it's not too bad. If you make them out of steel, the organic acids, the organic compounds are in the steam, and they're going to start eating the roofs of those buildings. So putting a metal roof on isn't always best. You may want to put a wood roof on so that it doesn't start pitting, rotting, rusting, whatever. And even the aluminum will end up rusting. When we use metal in compost systems, oftentimes it'll be stainless steel, and that will be an in-vessel type unit that would be stainless steel, because it's worth spending the money on that mechanism so that it doesn't rust. Multiple bins, large scale, very large building, so you can size them all different ways, and I encourage people to size them with what equipment they're going to use. If you have a 6-foot bucket, don't make your rows 4 feet wide. It's not going to work. Make them 6 to 7 feet wide so that you can get in there and use the stuff. And that's why we don't give you dimensions for these kinds of things, because you're going to develop them based on some equipment. You might have a double wide system. It might be a 12-foot wide bay that your 6-foot wide loader can work in. So you're going to decide how much capacity you need and how much of all that kind of stuff. And we have capacity calculators for some of that kind of stuff on our websites for butcher waste and for all types of composting feedstocks. And one is called Co-Composter, and that's for windrow composting or other things, and it tells you how much time, how much money, all those kinds of things that you're going to need to process that material. There's another one, just you can see this one was at a university, and they've put extra air vents in here all around so that some of the steam is going to be going out of that building and it will not land on the roof the ceiling of the building and stuff like that. So they've just incorporated more airflow. They do have plywood sides in there, but the feedstock is against the cement. Again, wooden sides. DOT in the state of Virginia decided to use big bins, and then they overloaded the bins because they had more deer than they had space for, and it caused problems. So they're going away from bins and will go to windrow processing probably. So you may not need the structure that you have. You may. Cement bins are not going to rot as easily. They also don't allow for as much airflow, so you're going to have to get your airflow from the front. Your record keeping doesn't have to be rocket science. It can be very simple, but some type of record keeping. What I tell most of my farmers is when you're composting, just keep a calendar in your cab, the cab of your loader, and mark down when you turn things. Mark down when, it doesn't have to be, you can always go back and see. You don't have to, write them and put them in Excel files or any of that kind of stuff. Just keep some kind of record so that you can go back and know what's happening in that process. And for regulation, you need some of that information, so that's important. These are very large Jersey barrier windrows, and they cure their material in here. They have a digester, so the digester pre-processes the fiber, the material, the manure. Then it's dewatered with a separator, and then it goes into those for curing. In composting, we always have an active period and a passive period, a curing period. So we have both parts of the process. When somebody tells you that you can compost in 21 days, they're probably full of it. It's not true. We really like to, any composter who's been composting and who knows these things is going to say, the longer the better, and in the Northeast, work with our seasons, because we're not going to sell most of our compost in the wintertime. Probably not any of it in the wintertime. We might sell some in the fall, and we're going to sell a lot of it, most of it before Mother's Day if we're good. And that's what we have to be thinking about with our processes. If somebody promises you something and you have a finished compost that's 2 months old and it kills somebody's $1 million poinsettia crop, you better hope you have good insurance, because you just sold them something that was going to kill their plants. And that's important to know. Most farm insurance covers those things, but you need to make sure that even if you're a really good composter, that that problem isn't going to occur for you. In here, they started with a forced air system. Then they turned the forced air off. Then they took the pipes out eventually. So they were getting enough air in their system is the point. They do use pipes, and occasionally for some of their processing, they use a JVC loader that works well in those pipes because it's easy to crack those pipes when you're working with heavy equipment around those pipes. So they used they designed their system for the equipment that they were going to be using. This is an interesting one. We're getting up in technology, so I keep increasing technology here. But this is actually a heat transfer system, and it's one we're working on right now. We have 2 of them up and running, the first one in Vermont and one in New York now. And basically we are harvesting the heat from that and producing a compost product. What they do is they have air channels in the bottom, in the floor there, and they put pieces of pine wood with holes over top of those, and then they have big holes in the PVC pipe, little holes in the boards. And that's to protect their airflow system. And they're using the airflow well in this situation. They have it on very short periods of time. Then they put the material in there, okay, so they take it and they use it as a block. So the whole thing is full of manure. They can put it in by windrow, and that's how they would tend to do it so that they're organized. So you put it in, temperatures rise, and then air, the fans, will draw. There's a heat transfer unit that you're going to see as I go through the slides. But the fans will draw the heat through the compost pile, so they're not blowing, they're sucking. So they're sucking the heat through, and then that heat comes into a heat exchanger, and we can either generate electricity with those, or we can heat hot water with those, or there are different ways that we can do it. It's Canadian technology. So that fan is the only working part in that whole operation. So nothing is going to break in there. It goes into this thing. There are Freon-filled tubes in here. They collect the heat. They heat the hot water. The hot water heats the farm, and then they can sell off the excess heat. So that type of building is coming. We're working on it. It works as well as probably a digester is going to in generating energy. But it's a slower, lower tech way to do it. It's good for on-farm use, horse farms, you know, places that have that kind of stuff. That particular operation with building the barn and all of that kind of stuff, that's only half of the barn that you saw there, is about $1 million. Or three quarters of a million, but that's going to heat. I don't have all their figures in my head on what, but it's saving them huge amounts of money. That's a CIG grant and a CIG and a NYSERDA, an energy grant, that was funding that one. But the operation in Vermont that's 3 years into the process is making money because they're selling their compost and they're using their energy to heat the floors of the calf barns. This one is a Green Mountain technology. There are little systems. As you can see over here, that's an earth tub. And then there are very large systems. So universities are tending to use some of these. They do have a motor that allows it, that circulates it around because they found them a little hard to push sometimes. But that basically, that auger allows for the composting process to work. And there's an auger in there. Then you can take some material out of this door over here as that finishes. Some people like them, some people don't. Then these up here, those are like tractor trailer boxes. And those are batch systems. So you can have a batch system, you mix all the material, you load it all into that system, and then it works. There's forced air tubes that are going through those, and it works. There are also continuous feed systems where you put it in the front end, and it goes through that whole system. It's moved, conveyed through that system, and reaches temperature all the way at the other end, and then offloads by itself. And there's a Wright environmental technology, that's another Canadian technology, that has a system that does that. They're expensive. But when I see people putting digesters on farms, and we're spending $2 million on a digester, and then I always thought that was really expensive. And then I say, okay, well, I could spend $500,000 on another piece of equipment that can give me stable products and something to sell and all that stuff. I'm thinking it's not so expensive anymore. And then it may have, it begs us to think about it a little bit more. What are we spending money on? There are rotating drum composters. Is anybody in New Jersey using DMS, dairy manure solids, for bedding? Yes, they're starting to do some of that. A lot, a little, yep. And we've done a bit of research on that because the question came up, and we really do a lot of compost and waste disposal. We don't do a lot of cows and stuff like that. We deal with the waste products from stuff like that. But we were asked to deal with the bedding issue because people wanted to know whether the dairy manure solids needed to be composted fully before they were used again in the barns. And so there's a whole research project on our website on that. The quick answer is no. We don't have to fully compost things, and actually it might work against us because we'd be killing the organisms that may be out-competing the pathogenic organisms coming out of the end of the cow. So if we had a salmonella outbreak or something like that with the cow, then that salmonella would be able to colonize and go crazy versus other competing organisms being able to wipe it out. And so we use some rotating drums for mortality, very limited, and some for manure for preparation. But again, there's more expense there. So is it enough? Is it giving me enough of a product to use to pay that to do that? So we always have to think about the costs and benefits of all of these systems. One of the problems with these is you have to get the mix right. So if your carbon to nitrogen ratio and your moisture are not really good, they're going to leak. And they seem like they're a solid drum. Their seals do leak, and we've gotten them to leak in most of those in-vessel units. because somebody will make a recipe, have an incorrect recipe or something like that, or the moisture will get out of whack, and then they'll start leaking through those seals. That can create an odor issue. That's mainly the problem with something like that. You can know what's going on in those because they have temperature probes in there. You know what, you can check what the moisture is, but moisture meters in the long run don't work that well. So in vessel, back to that, there are different types, and one of the reasons that they started with the rotating drum stuff is in the South, when they were composting chickens, they started putting them in cement mixers because they thought they could make that work. And it works okay, it's not great. So that's the bottom line on mortalities in vessel drums is I haven't seen anything that was that great that it's worth buying that piece of equipment at this point. People are working on it. I think it has promise, but it's going to come down to the recipe. And when you have a chunk of animal and carbon, it's really hard to make that recipe that perfect. So small pieces I think you could do in a rotating drum. Forget about putting a cow in. It's going to go clunk, clunk, clunk. You know, it's just not going to work for you. This is an extremely sophisticated $10 million facility. It's a very rural community, but it is New York City's watershed. So all of the New York City water comes from here, so they felt it important to protect the water in that area. Biosolids, which is human manure, some calf manure, garbage, anything that we want to put in that facility goes in that facility. What happens in there is it uses multi-technologies, and so this is a rotating drum. It's inside there, but this is a picture that was taken when it was outside. But the rotating drum is in here. It goes into the rotating drum right here. Then it goes through here, goes to a picking line. So if there's garbage, a lot of garbage is pre-picked. If there's a mattress, a stove, or something like that, that's pre-picked with a large piece of equipment. Then it goes into a picking line for smaller stuff. People pick that. The garbage goes one way. The organics go the other way. And then these are automatically turned windrows, okay? So they go back and forth, and there's an automatic, there are bays, so they have cement bays in between the windrows, and the windrow turner goes from one bay, it moves itself over, comes down the next bay, moves itself over, comes down the next bay. And that happens automatically. Does it ever screw up? Yes, occasionally. Sometimes that train goes off its track and somebody has to put it back on. But it's an automated, highly automated system generally used for biosolids and mixed waste composting. So that's the top end, the Cadillac of what you're doing. But that's a $10 million process. As you can see, they generate odor, and the odor is really bad. I've gone in that facility to test, and I couldn't stand myself coming out. So they have biofilters, and these are biofilters that are built outside the plant, and the air that comes out of that plant, and as I said, this is extremely rural area, so it doesn't matter where the air goes, but it's important to control that. It goes underground and comes up through that biofilter. Biofilters are made of organic material generally, wood chips, shavings, that kind of stuff. This is what you were asking about with the liquids composting. It's not an in-vessel, it's outdoors, but I wanted to make sure that we talked about this, and we usually need to in composting classes. So this is a windrow of carbon. It's leaf and yard waste. It's downtown in Burlington, Vermont. What they've done is they've made dams. There's a dam, there's a trough, there's a dam. Then they take 15,000 gallons of Ben & Jerry's waste, the rinse, the milk, the bad batches, if there are any in Ben & Jerry's. They put that in there slowly. And remember, we're on a 1 to 2% slope. So if we blow out the end of our pile, it's going to really be hard to pick up liquid. So we don't want to do that. So we put dams in there and make sure that we're putting it in slowly. When it comes out of the tanker, it goes into those cells slowly. We let it soak in. So if it's blood, if it's whey, if it's any of those things, we're going to just let it go in there, and we're not going to end up turning it. We'll just cover it over. Nicely, gently cover it over, because we don't want those odors to come out. We don't want to turn those odors. With this particular situation, that's a windrow turner that's coming through that row and turning that, because it's milk waste and we can process it more quickly if we turn it. And that's the method that they use there. We have a fact sheet that's written on composting liquids specifically. It's the solids, the liquids and semi-solids like coagulated blood that can go into these type systems. Okay, and I think that is it.